So let's return to looking at the relational model, and later on we'll look at selection. So we'll start off by specifically looking at the relational model in more detail, and specifically I want to talk about keys. Now, we know that this table, this relation, is a representation of the data. It's an abstraction away from the binary patterns, the bits and the bytes, and the very low level detail that's required to store this data on the disk. And of course, one of the issues with that is that we may well have inadvertently removed our access to part of the data by doing this abstraction, by taking this higher order view of the data set. So what's very important is that we can still actually gain access to all the individual parts of this data, the individual rows and the individual columns. Now, how do we actually gain access to parts of this table? Well, if we want to gain access to individual columns, we know from our previous work that each column has a unique name, a unique attribute name. For this relation, for this table, every column, every attribute will be unique. So we've got emp number, ename, job, manager, etc. all across the top. And those attribute names give us access to each column. You know, if we wanted to pull out ename, we can just pull that. If we want to pull out the third column, that's job. If we wanted to pull out the fifth column, that would be hire date, things like that. But how do we actually then access individual rows, individual tuples? You know, we really want to be able to sort of gain access to that particular row, 535 or 557 or 602. Now, keys are a way for us to actually uniquely identify particular rows. Now, we're going to look at various types of key here. So I'm just going to work my way through them. We'll start off with what's known as a superkey. And the definition of a superkey is an attribute, so in other words, a column, or a set of attributes, so in other words, a combination of columns, that when you look at the data values in those, it will uniquely identify a tuple within relation. Now you can visualize this as being like, if you use the key, if you use this key, whatever this key is, you will only get one row back. You will only get one tuple back. It has that uniqueness property that we're actually looking for. So if we actually look at the emp table again, then if we scan across the columns, if we were to provide an emp number, so for example 602 or 405, that will return a single row and only ever return a single row. And that's that property of uniqueness. It will return a single row. So, you know, 405 will return that row and only one row. 602 would return that row and only that row. 912 would return that row and only that row. So because emp number will only ever return a single row, it will return a unique row, we know that it is a superkey for this table. Now, of course, using that combination of key and attribute basically enables us to gain access to every single value in this table. You know, you can ask a question like, what is emp number 912's job? So 912 is that particular row, and we know that we have a job column, and we know that we can then gain access to the fact that that person's job is in admin. If we had something like 875 salary, again we can scan across. We know there's a salary column, and that gives us the 60,000 figure. Now, keys fall into these different categories, and we've talked about a superkey being an attribute or a set of attributes, a column or a combination of columns that when you use them will uniquely identify a tuple within the relation. In other words, it will give you that row back, that one row. Now, we'll talk about the other types of key in a second. Superkeys uniquely identify a tuple within a relation, but there's not just one superkey. There could be many superkeys. So we know that emp number is a superkey. You know, if I say 912, that actually gives us that one particular row. But what other superkeys are there? And there are choices here. There are other types of superkeys in the table, and it will depend upon the data in the table, the columns that you have. All sorts of factors will influence how many superkeys there actually are. So what about ename? Well, ename, if we were to look at this particular table, if we were to say who is March, that will only return one row, just like that. If we say who is Reese, that would return one row. So in a way, ename would be a superkey because it only returns one row. And that's that definition, that uniqueness definition that we're looking for here. But of course, the thing about ename is that it works right now, but what happens in 5 minutes' time if we employ someone with the same name? So we actually, when we're doing this, we have to think about what's the data set look like now, but what will the data set look like in future? We have to project it forward. But just for example's sake for here, let's assume that ename is actually a superkey. Now, if you return to the definition of superkey, then we know that a superkey can be a single column, but it can be combinations of columns as well. It's a set of attributes. It can be a set of attributes. So superkeys could be things like emp number ename, emp number job, ename job, emp number ename job, and you could just carry on making lists up of these different superkeys. We could create a set of what are the different superkeys that would be appropriate for this table. So here's emp number ename. Now there's no mathematical formula to calculate the number of superkeys because it depends on the actual context of the column. You know, what is a name? Our name's unique. What is a job? Our job's unique. So really this is something that we have to think about when you're looking at the context of the different columns and what the table actually represents. So you have your table and there are a whole collection of superkeys. Which one is better? What does better mean in this context? Well, you could take your list of superkeys and you could try to determine which ones are candidate keys. So you have this huge selection of superkeys, all these different choices that you have, and we narrow it down to a collection of candidate keys. And candidate keys are superkeys which are minimal. Now, minimal basically means they're the smallest they can possibly be while still being a key. So we're still looking for that that notion that it's got that uniqueness property. It's still returning one row from the table, but what we're really looking for is the sort of the better keys. And here, when I say better, what I mean is minimal. Are they as small as they can be? Now, this is a bit odd, but the way that you can determine whether something is a candidate key is by seeing if you can throw something away. If you can throw something away and it's still a candidate key, if you can throw something away and it still sort of has that key property, then you know it wasn't minimal in the first place, which means it's not a candidate key. I'll say that again. If you have something, if you can throw part of it away, then you know it's not a candidate key, because the whole point about a candidate key is that it is minimal. It is the smallest it can be. So have a look at emp number job. Now, emp number job is a super key. If we supply emp number and job to the table, then we will get one row back. But let's have a look at that. We know it's a super key. Is it a candidate key? Now, what we could do is we can cross out job. And when we cross out job, emp number job becomes just emp number, and it is still a super key. So because we could take that key and we could throw part of it away, we know it's not minimal. It could be made smaller. It's not minimal. In other words, emp number job is not a candidate key, because candidate keys, you can't shrink them. They have to be as minimal as they can possibly be. So emp number job is a super key, but it's not a candidate key. And what you could do is you can just work your way through all the different super keys and see if they are as minimal as they can possibly be. So let's imagine that you had this list of super keys, and you can see they're all super keys. If you trace down the super key column, you can see that we have a long list of ticks there which indicate they're all super keys. Are they candidate keys? And so we're looking for that minimal property. And so with emp number ename, we could throw ename away. In other words, it's not a candidate key. Emp number job, well, we just threw job away. We know it's not a candidate key. We know that ename isn't a really good thing, but I've just left it in the list here anyway. Ename job, we could throw job away. It's not a candidate key. Emp number ename job, well, we could throw job away. We could throw ename away. It would still be a super key. It's not a candidate key. And eventually you whittle it all the way down to the remaining collection of candidate keys. Now I've left ename in here as an example, but I've already pointed out that ename isn't really the appropriate choice for a candidate key. But anyway, you would have a selection of candidate keys and you go, okay, what do I do now? Well, you choose one of those and one of those becomes your primary key. And when I say primary key, this is the one that you will use in the day-to-day usage of that table, of that relation. So to summarize then, you have a huge collection of super keys, keys which in other words will give you a row from the table. Some of them are going to be kind of bloated, inefficient. And what you do is you narrow them down to a selection of candidate keys, the ones which are minimal, efficient if you like. And then from the candidate key list, you choose a primary key. And often that choice will depend on the context. You know, you might look at it and go, oh yeah, clearly this particular column here would be perfect for our primary key. If you don't have one, you might actually have to make up a column. So we would end up with something like that. That distillation from super key to candidate key to primary key. So we've done super keys, candidate keys, primary keys. There is a different kind of key, which is the foreign key. Here's the definition of a foreign key. A foreign key is an attribute or a set of attributes within one relation that matches a candidate key of the same, possibly same, or some other relation. And I think if you see a diagram for this explains it. And it's the emp department tables that best show you this. If you have a look at the emp relation, if you think about what we were just looking at, what's the primary key for the emp relation? Well, it's very straightforward. I hope you can see it's the emp number column. Now have a look at the department table, the department relation, and you can see, okay, so what's the primary key in this table? Well, fairly straightforward, department number. But now we know that department number is in the emp relation. So emp number is a primary key in the emp relation. Department number is a primary key in the department relation. But department number also appears in the emp relation, and it's a foreign key. It's a foreign key because it's a primary key in a different table. And what that foreign key relationship is actually telling us is it's actually, as it says, it's telling us about a relationship between those two tables. Now, when you have foreign keys and primary keys, there are rules that have to apply, and those are in this category of things that are called relational integrity. And so I'm just going to blitz through those integrity rules. Entity integrity basically says a primary key must never be null. Now, if you think about it, there isn't for a primary key must never be null. Is clear if we actually remove some of the emp numbers. So for example, if we have a look at this, say I remove the emp number for Bell and Pollard. Let's imagine that I allow primary keys to be null. Null here means blank, empty. What we've done now by allowing a primary key to be null is we've lost that retrievability process. I now can no longer call out emp number and get a row back from the table for every single row. I've broken the primary key. So primary keys must never be null. Clearly I would have no way of pulling out the different rows, Bell and Pollard. So that's entity integrity. Referential integrity is about foreign keys. And here it says that a foreign key must either match a candidate key value in its home relation, but it can be null. So again, let's have a look back at the example. So have a look at the department number column, which is in the far right of the EMP relation. You can see, as we scroll down, you can see all the different department numbers that we have. 233, 2331. So that definition of integrity when it comes to foreign keys basically says these values must be values that are our primary keys in the other table. So in other words, those department numbers, it makes sense really, those department numbers must be actual departments in the department relation. 233, 233. It wouldn't make sense for us to scan down that list and suddenly find department 78 because there is no department 78 in the department relation. Those values must be over there. Now, the other part of the definition is that it can be null, and it's only true for foreign keys. So these values could be null. So remember, this isn't true for primary keys, this is only true for foreign keys. If you think about that, what we're actually suggesting, it could be something like Bell has been hired in this instance, but hasn't been associated with a department just yet. So foreign keys either have to have a value which comes from the other table, but they can be null. Primary keys must never be null. Now the third type of relational integrity that we have are these things that are called enterprise constraints. And these are rules specified by the actual scenario, the system, the problem domain that you're dealing with. And those are kind of, often they're like business logic rules. So it could be something like only salespeople can earn commission. All departments must have a location. Everyone has to have a line manager apart from the president. And what you can do is you can actually define those rules in the database product itself. So if somebody attempts to update or insert a record or perhaps even delete a record that contravenes one of these rules, some kind of alert goes off or that process is forbidden by the interface.